Hello, so the first part of our lecture for today is liniments and homogeneous ointments. Here is the recommended literature. You can find all of the needed material in our formal course. So we are going to talk about characteristics and classification of liniments, general rules of ointments preparation, characteristics and requirements to ointment, classification of ointments and ointment bases, preparation of homogeneous ointments. So firstly, we start with liniments. Liniments, also called liquid ointments, they are medicinal forms for external application. They are in the form of dense liquids or gelatinous masses, melt at the body temperature, and are used for rubbing into skin. They are classified into fatty ones. This is most of them. So they are preferred with the use of dispersed fatty medium. Alcoholics, so basically these are all that include some quantity of alcohol or tinctures usually. It doesn't mean that alcohol is the main there, but it is included. Vasoliments, that those are based on vaseline oil, and soapy alcoholic. You have there some tinctures or some alcoholic solutions together with some soaps. By their system, they are divided into liniment solutions, liniment suspensions, liniment emulsions. They can be liniments alloys. So basically homogeneous and heterogeneous. They are prepared by the general rules of liquid medicinal forms preparation, but not as aqueous solutions, but as oily solutions, because they are based on oils, mostly on oils. And I hope that you remember from the first semester that when we prepare non-aqueous solutions, we have this topic, non-aqueous solutions, where we calculated some alcohol. And there we also revised how to dissolve something in oil. And here are the same rules. So basically it is oil solution. Homogeneous liniments are usually prepared directly in the bottle for dispensing. In most of liniments, they are homogeneous systems, so this is what you're going to do. We remember that oils are viscous liquids. They stuck to everything they touch. And we have great losses. And because of that, we prepare them straight in the glass bottle for dispensing. Also, there are no coefficient of volume increase, percent is, it doesn't matter because density of all these oils and other liquids like ether, chloroform, methyl salicylate, turpentine, they all are different. No CVI, no percentage taken into consideration. Just put everything straight into the glass bottle for dispensing, close, shake, and your homogeneous ointment is ready. Soluble medicinal substances are introduced into liniments according to their solubility. So everything that is prescribed in oils, you firstly put the substance, then on top you put oil, close the bottle, shake it, your liniment is ready. If you need to prepare liniment suspension, we're going to revise only one today. You need to use a mortar. And in that case, you just prepare it according to the Diriagin's rule, like all other suspensions. Emulsion liniments, you're going to learn only one. That is prepared through the chemical reaction, so no specific rules there are needed. Medicinal substances soluble in oil, medicinal substances soluble in liquids, and medicinal substances not soluble in anything and soluble in water are introduced according to their chemical properties. When they are dissoluble in oil, you dissolve them in oil. When they're soluble in some liquids and you have them prescribed, you dissolve it in these liquids and then mix with the bases. If you have substances not soluble in anything, you introduce them by the suspension type according to the Diragin's rule. If you have medicinal substances soluble in water, you dissolve them in purified water or in some aqueous solutions and then emulsify and add to the rest of the liniment. Let's start from the very beginning. For example, you have liniment solutions like this one, chloroform, sunflower oil, and turpentine. They are all mixable. They are on a liquid condition, so you just mix them all together, close the bottle, shake, and that's all. Everything's ready. So the given medicine is a liniment solution containing strong, effective, light-sensitive substance chloroform, aromatic substance turpentine, and light-sensitive substance sunflower oil in its composition. All three liquid components are mutually insoluble in each other. That is why you just take glass bottle for dispensing. For liniment, it should be of clear glass because you need to see what's going on there. If you have some light sensitive substances like here chloroform, you can take orange glass. So you take a glass bottle of orange glass, weigh there, not measure, only weigh viscous liquids with the help of balances. Weigh there 20 grams of sunflower oil, 10 grams of chloroform, and 20 grams of turpentine. And the total mass will be 50 grams. You just close the bottle, shake it, and that's all. Next one, liniment suspension. You're going to learn one that is called liniment by Vishnevsky. It's very popular. It is one of those liniments that are still used because it's a very good remedy to treat different kinds of wounds. Liniment suspensions are prepared by the Dirac rule. And there is a peculiarity. So it is called Vishnevsky liniment because basically it is an author prescription. It was created by doctor with the surname Vishnevsky. And when he created it, he had done all ingredients replaceable. For example, you can take Seraform. If you don't have any Seraform in your pharmacy, you can take Dermatol, the same substance with the same pharmacological activity. If you don't have tar, you can take vanillin instead. If you don't have castor oil, you can take cod liver oil instead. So, and you have lots of tests. What should you take in case if you need to prepare Vishnevsky liniment and you don't have any Seraform? So the answer will be take Dermatol. And all of these substances, they are replaceable, so please pay attention. As for the ratio can be a 1-to-1 Xeroform and tar or 1-to-2. So it can be different depending on what properties do you need to get, more wound healing or more antiseptic, so it depends. How to prepare it? By the Dirac rule. So you take Seraform, put it into the mortar. It is not dermatol. They are not insoluble in anything. Both of the substances, you grind them in dry condition. Then by the Dirac rule with a half amount of tar or vanillin. Then you add the rest of tar or vanillin, mix it all together, and add all quantity of castor oil or cod liver oil. And your suspension, your liniment suspension is ready. You transfer it straight to the glass bottle for dispensing. Liniment emulsions, again, you're going to learn only one, this one that you can see on your screen. Unlike liniment by Vishnevsky, where the ratio can be different, here the ratio is very strict. It is never changed because it is formed through the chemical reaction, and ratio is very important. The composition of liniment emulsion includes the following: sunflower oil 74 grams, solution of ammonia 10%, 25 milliliters, and oleic acid 1 gram. Altogether it is 100 grams. How to prepare it? You take glass bottle for dispensing. Place there 74 grams of sunflower oil. Add 1 gram of oleic acid by drops. Close the bottle, shake it good so that oleic acid is spread and mixed with all quantity of sunflower oil. Then you open it up and add 25 milliliters of 10% solution of ammonia. Close bottle and shake it once more. Chemical reaction happens between solution of ammonia and oleic acid, forming emulsion. Very convenient and easy to prepare. Emulsion is oil in water type. because of the origin of the formed emulsifier. So this is what you do. Quite easy to prepare. Basically, this is kind of everything, but also I would like to pay your attention to back to Liniments solutions with camphor, menthol, and anesthetine. Camphor, menthol, anesthetine, and the rest of substances, they are very easily soluble in oil, but they have a peculiarity. The peculiarity is the following. Now, I hope you remember from powders that camphor, menthol, and anesthetine, when they are mixed together, they form eutactic alloy. Crystals form liquid, and this liquid is not mixable with anything. So when you have camphor, menthol, and anesthetine prescribed together with sunflower oil, to avoid formation of eutactic alloy, you need to mix them separately. Firstly, you mix camphor with oil, close it, and shake it until camphor is fully dissolved in oil. Then you open up the bottle, add menthol, close the bottle, shake once again until menthol is dissolved completely. After that, you add anethane. So basically, you just dissolve all the substances, not all together, but separately, one, then the second, then the third, and so on. In that case, you don't have any problems with getting good, stable system. Now we move to ointments. Basically, liniments, they are very rare these days because the liquid is very oily liquid. It's very inconvenient somehow to use it. Usually it is used for soaking some material and to put it on wounds. So somewhere in hospitals they are used. At home it's hard. So mostly when we talk about semi-solid dosage forms, of course, these are ointments. So they are semi-solid dosage forms intended for application on skin, wounds, or mucous membranes. There are different kinds of ointments. They can be applied on skin or mucous membranes with the formation of smooth entire film on the surface. They can be previously applied in close non-woven materials, and they can be in a composition of modern transdermal therapeutic systems. It's a very interesting thing. That is very convenient to use. So you just apply it on the top of wound, for example, and make it closed for 1 day, and after that you just change it. Very convenient to use. And also it can be in a form of aerosol packaging. So all of that stuff that is called sunscreens, lotions for healing wounds and so on, it's also kind of semi-solid dosage form. It's also kind of an ointment. Ointment should have optimal, not the smallest, not the biggest, optimal size of particles. It should have soft consistency. It should be stable in process of storage. It should be providing necessary pharmacological effect. It should not contain any microbes, of course. No negative interaction between auxiliary and medicinal substances, and absence of toxic and allergic reaction. By the field of application, ointments are divided into ointments for skin application and transcutaneous, the main one, so-called dermatological ointments, ointments for applying on mucous membranes, ointments for applying on wounds and burn surfaces. The last one, they are specific. When we talk about applying something on open wound, so we're going to have contact with blood, or burn surfaces, also contact with blood, and these ointments must be sterile and aperogenic. By prescription, they can be medical and cosmetic, all kinds of creams and gels. This is also ointments, cosmetic, and of course, medical traditional one. By composition, simple and complex. When you have just one ingredient, it is simple ointment. When you have two and more, it is complex ointment. By consistent, these are ointment themselves, pastes like toothpaste. Toothpaste is also a kind of an ointment. Creams, gels, and liniments. By their effect on the body can be local and general. 99% of ointments, they are local. It's very hard to get some systemic effect. I cannot even give you the example of such an ointment. This is more about transdermal system. They are new one. When transdermal system, this is something else. They really can get some little penetration. In any case, penetration is not so big, but it can be. Transdermal system can be, how to give you the example, maybe it is for those people who want to quit smoking, they get a kind of a specific plaster on top of their skin to put some nicotine to the blood to avoid this desire to smoke more, something like that. So it's very specific and it's very rare. Most of ointments, they have only a local effect. By dispersed system, they are divided into homogeneous, and here we have not only ointment solutions, but ointment solid, extraction ointment, and combined ointment. What's that? Ointment solution, this is the most simple. Or when you have substance that is soluble in the prescribed ointment base. Ointment alloy, this is a combination of some fusible mutually soluble components. For example, it can be oil and paraffin. And when you mix them together, basically you get an alloy. Extraction, very rare these days, but still you can mix them. This is when you melt the ointment base, mix it with some plant raw material to get the process of extraction. After that, you melt it once again, filter all this plant raw material, and basically you got the process of extraction, but not with the use of a normal solvent, but with the use of the ointment base. It's very rare. Combined, this is when you, for example, have substances that are dry but soluble in this composition, and also something that forms alloy. Heterogeneous, suspension ointments, when we have substances not soluble in anything. Emulsion, then we have substances soluble in water, but you need to put them into Vaseline, for example. And combined, this is vast majority of extemporaneous ointments, when you have both solution, emulsion, and suspension all together at once. One more thing. When we decide how to introduce medicines into the composition of the ointment, we evaluate their qualitative and quantitative content. If you have substances soluble in the water in quantity up to 5%, they will give you ointment emulsion. You will dissolve them in water. If you have 5% and more, then you introduce them by the type of suspension. So basically, suspension is kind of for the main one. If you have the solid phase more than 20%, it is called paste. Remember pastes, they're quite tough. Or maybe you also have seen toothpastes that are not pastes generally. They're called tooth gels. They are softer. So these are different kind of dispersed system and different kinds of dosage forms. Ointment base is something very, very important when we talk about liniments and ointments, because this is what gives us their form. It is a carrier of a dosage form. So it is very important to choose a proper hydrophobic or hydrophilic ointment base. If it is, mostly it is hydrophobic. Because hydrophobic bases, they are absolutely neutral for our skin. They don't do anything to our skin. They are not absorbed by our skin. They don't do something bad for our skin, and that is why it's very convenient for them to use. The main hydrophobic base for ointment, this is Vaseline, of course. Vaseline is made of oil. It is absolutely neutral for our skin, never causes any allergic effects, nothing. It's absolutely safe. And also it is called a surfactant base, because it is not absorbed by our skin, because it is of mineral origin, not of natural one. And it forms kind of a film on top of our skin surface and protects the wound, very convenient. Among other substances of oil or oily fatty origin, this is also lanolin. Lanolin basically is an emulsifier. It's very convenient. It is obtained from the wool of sheep. So when wool of sheep is collected, it is washed before making the wool itself. And lots of lanolin is obtained. We still get so many wool from sheep, and that is why there is lots of this lanolin available. Lanolin is a very good ointment base. It's of absolutely natural origin. It can be absorbed by our skin. It just has a specific smell. But also it is a wonderful emulsifier. This is the main emulsifier in ointments. It gives us emulsion of water in oil type. Very convenient to use. So it can be called so-called diphilic base. The last one, hydrophilic. Hydrophilic bases, the ones that you have seen for sure, these are all kinds of gels. All kinds of gels, they're hydrophilic, of course. Made of starch, cellulose, collagen, agar, gelatin, alginine, lots of them. And of course, we have polyethylene oxide. Polyethylene oxide is a wonderful base. It's very convenient in usage. It is never contaminated by microbes. It fully mixable with absolutely any quantity of soluble in water substances. You can heat it, you can melt it, you can do whatever you want. It is 100% synthetic and absolutely non-toxic, but it has one peculiarity. It has very high osmotic pressure. What does it mean? Osmotic pressure means when you apply it on the wound, it absorbs water and absorbs a lot. That is why polyethylene oxide ointments are very popular when you need to treat something where you have some infection or you have some burns. When we have burns, we have lots of exudate and we need to clean the wound. And polyethylene oxide is the best choice. It's going to absorb all of this exudate and clean the wound. Wonderful choice. The same about infection. When we have some kind of wound with infection, all of this and purulent and all of that. And again, we need to clean the wound. So polyethylene oxide is the best choice in here as well. And also it just boosts their pharmacological active substances out of it with a very powerful local and partially systemic effect. But if you try to apply the ointment based on polyethylene oxide on normal skin with no wounds, with no burns, systemically, then you're going to have itches. You're going to have chemical burn in the place of applying of this ointment, with this base. But this should be done at least for 3 days and more to get this irritation. Up to 3 days, no irritation. That is why polyethylene oxides are very good for all kinds of ointments with antibiotics, with sulfonylamides, with different kinds of antibacterial activity, for healing of burns. But it is not recommended for the usage on normal skin, and it is forbidden to be used for kids because they have very sensitive and tender skin, and they may get some bad effects after the usage. So, ways of prescribing ointments. Usually the doctor prescribes to us the substance that he wants in quantity that he wants and gives us the ointment base that he would like to get. It's very convenient for us. Like here, menthol 0.1, Vaseline 10, ointment for nose. Very clear for us what to take. But it's not always this way. Sometimes the doctor can prescribe to you just unguented zinc oxide is 3%, 10 grams, and that's all. Out of this, we understand the concentration of zinc oxide must be 3%. The general mass should be 10 grams, but what base to take? When the doctor does not specify to you which base to take Vaseline, always. Also, the doctor can prescribe to you the ointment like that one, unguentic xeroformi 100 grams. No percentage, no base. But we already know that when base is not specified, take Vaseline. Okay, what about the quantity of xeroform? If the quantity of the substance is not prescribed, prepare 10% concentration. So if the base is not prescribed, take Vaseline. If percentage of active ingredient is not specified, prepare 10% concentration. So, what do we have? We have the prescription formula into the pharmacy. We get it, we analyze it. It should contain all kinds of additional substances prescribed, all the signatures, all the stamps, all of that. After that, we analyze the amount of our substances. Substances soluble in water, substances soluble in oil, substances not soluble in oil and in water. And we evaluate the quantity of these three groups by the quantities up to 5% or 5% and more. Depending on that, we have different technology. For example, when we talk about substances that are soluble in oils prescribed together with vaseline, so if it is up to 5%, you can dissolve them in the equal amount of the liquid suitable for the base and its properties. For example, for vaseline, it will be vaseline oil or so-called liquid paraffin. If it is 5% and more, you cannot use additional liquid. You need to dissolve it in the amount or in the same amount of melted base. It's a little bit harder, but when we have 5% and more, we cannot use additional liquid because ointment is not going to get the proper consistency. And that is important. For example, again, you got this ointment. Menthol 0.1 gram, vaseline 10 grams. Miste ut fiat unguentum. Da signa, ointment for nose. On the reverse side, firstly, we start with calculating the general mass of ointment. Everything prescribed in grams, so we have 10.1 grams general mass. After that, we calculate percentage of the dry substance. 10.1 is 100%, 0.1 is X, calculated crisscross as usual, and we get 0.9%, which is less than 5%. Therefore, we can take vaseline oil for dissolving menthol. How many oil do we need? It is taken in the same quantity as quantity of the substance we need to dissolve. For 0.1 gram of menthol, we take 0.1 gram of vaseline oil. It is recalculated into drops. In our guides, you open up the table quantity of drops in 1 gram or 1 milliliter of liquid and find there that 1 gram of vaseline oil is 24 drops. And we need 0.1, it's approximately 2 drops. How to prepare it? Take a mortar, place there menthol. On top of it, you put 2 drops of vaseline oil, mix it with the help of pestle until complete dissolution of menthol. Then you add 10 grams of vaseline, mix everything until you get good homogeneous mess and transfer it to the jar for dispensing. On the front side of written control passport, respectively, you specify date, number of prescription, menthol. Menthol 0.1 gram, olii vaselini guttas 2, 0.1, 24 drops, vaseline 10 grams. Underline everything, general mass 10.1 gram, prepared by signature, checked by signature. Also, you can get this one, official formula of the camphor ointment according to state pharmacopoeia. And it includes 10 grams of camphor, 60 grams of vaseline, 30 grams of lanolin, or 10 grams of camphor, 54 grams of vaseline, 8 grams of paraffin, 28 grams of lanolin. If the doctor prescribes to you unguenti camphorati by State Pharmacopoeia of Ukraine, you open out State Pharmacopoeia of Ukraine, find it, and just prepare it according to this formula. So what do you do? How do you prepare it? You take non-aqueous lanolin and vaseline, melt it on the water bath. Then you add the camphor, volatile substance, in the dissolved alloy, cool it to 45 or to 50 degrees, mix it in the mortar until complete cooling down, and then place it into the jar. Next one, ointment that is called alloy. What is this? It can be something like here. Naphthalani liquidi raffinati, paraffini, petrolati. Petrolatum melts at the temperature 60 to 62 degrees. Paraffin is melted at the temperature 50 to 54 degrees. Naphthalani liquidi raffinati, this is a liquid. And we need somehow to make ointment out of these three substances. They are mixable and fusible. How do we take it? Firstly, we take a porcelain cup, place there, petrolate, put it onto water bars at the temperature 60-62. It melts, absolutely, it becomes a liquid. There we add some paraffin, mix it with the help of a glass stick, they melt together, then you just take it out of their water bath, add their naphthalene liquid, raffinati, and mix with the help of a glass stick. Altogether, after that you transfer it to the mortar, and with the help of a pestle, mix it until complete cooling down. Then you got a good ointment, which you after that transfer to the jar. You may ask me why should we place it into the mortar and mix it with a pestle if we can just put it straight to the jar. There is an interesting physical effect. If you make an ointment alloy and you skip this stage with mixing in a jar until cooling down, then when it cools down without mixing in a jar, in a mortar, it has the consistent like a lip balm. It's not an ointment, it's something hard. This is due to specifics of recrystallizing and building all these links between these three substances. But if you put it into the mortar and mix it with the help of a pestle for a few minutes, then cooling down goes the other way and you get good, semi-solid, consistent which you need. WCP front side respectively. You specify date, number of prescription, petrolate 12 grams, paraffin 18 grams, naphthalene liquid raffinati 70 grams. Underline everything, total mass is 100 degrees, prepared by and checked by. And we move on. So, these were the general rules of preparation ointments, liniments, and homogeneous ointments that were considered. Now I ask you for a few minutes to wait. I need to switch on the next information with the next topic for today about heterogeneous ointments. Just give me 1 minute, okay?